Okay, gentlemen, so today what we're going to do is look at an exam question. This is from November 2018, and I thought it was quite a nice question because it involves analytical geometry and actually a bit of trig, which will remind you about the trig that we've done. Okay, so very important, please make sure, please read the information before the question, before the diagram. Don't go straight to the diagram. There could be vital information that you need and you don't read about it and then you can't do the question. Okay, so we've been told that PQ is equal to QR. So I'm just going to do this. Okay, so those two sides are equal. PQ is equal to QR. PQ is perpendicular. Okay, well, they have got that one, the 90-degree angle there. T is a point on PQ such that T is the midpoint. Okay, so because that's the midpoint, we can say that PT is equal to TQ. S is a point of intersection of RQ and the x-axis, so that straight away I know that this would be x and a 0. Because the y value on the x-axis is always 0. V is a point on the x-axis such that QSV is 121, that's in there, and QPS is theta, which is in there as well. Okay, so now we're sure that we've got all the information that we need. So we are going to start with the question. So 2.1. Determine the length of PQ. Leave your answer in third form. Okay, well, distance x at P minus x at Q squared plus y at P minus y at Q squared. All right, and again, I often just write my coordinates here. So P is 1, 0, and Q is 6 and 3. Okay, so PQ is going to be 1 minus 6 squared plus 0 minus 3 squared. PQ is going to be negative 5 squared, which is 25. Negative 3 squared is 9. So PQ is going to be the square root of 34. And it said leave your answer in third form, so I'm going to leave it as a square root of 34. Gradient of PQ. Okay, I'm actually going to put that on the diagram. So PQ is root 34. Let's just write it here. And remember they told us that these two were equal, so this side here is also root of 34. Okay, so those two are equal sides. All right, 2.2. Find the gradient of PQ. Well, gradient, we know is a y at P minus a y at Q, change in y over change in x. Okay, so y at P is 0 minus 3 over 1 minus 6. So that's going to be negative 3 over negative 5, which gives me positive 3 over 5. And PQ does go up from left to right, so it should have a positive gradient. All right, 2.3. The coordinates of T. Well, T is the midpoint. So the x at T would be the x at P plus the x at Q over 2. And the y at T would be the y at P plus the y at Q over 2. Okay, so that's going to be 1 plus 6 over 2. So the x at T is going to be equal to 7 over 2, which is 3.5. And if you look at the x values 1 and 6, well, at least 3.5 looks like it's in the middle there, which is always a good thing. Okay, y at P, 0 plus 3 over 2. So the y at T is 3 over 2, which is 1.5. And again, 1.5 is between the y value 0 and 3. So it looks like I have got answers that are feasible. And then we would fill it in on the diagram. So this would be 7 over 2 and 3 over 2. Okay. All right. So those are the first questions. Now we're going to move on. We're looking for the area of triangle PQR. All right, so we've worked out that this is root 34. We know that this side and this side are equal. We know that this is 90. It was given to us. We've got this 7 over 2, 3 over 2. And we said this would be x and 0. All right, so how do I work out the area of a triangle? Well, the area of a triangle is a half times base times height. And because of my 90-degree angle, I can use PQ as a base and QR as a height. Or I could use it the other way around. QR as a base and PQ as a height. So because of that 90-degree angle. Now, if I hadn't read about PQ and QR being equal, I would have had to go and then do extra calculations and worked out the length of PQ, of RQ, sorry, but I don't have to because they told me those were equal, so they're both root 34, so that's going to be root 34 times root 34 is 34, divided by 2 gives me 17 units squared. So that was quick and easy. All right. Next question then. Find the size of theta. Okay. Well, I don't know how to find angles in grade 10. So what I'm going to do is I'm going to concentrate on this triangle here because it's a right-angled triangle. I know that this side here is the root of 34. I know that angle QSP is going to be 180 minus 121 because they're adjacent angles on a straight line. So that means QSP is going to be equal to 59 degrees. Okay, so this is going to be 59. Okay, can you see that I can now just use the sum of the angles in that triangle that I've colored in? Okay, so in triangle QPS, theta would be 180 minus 59 plus 90. So theta is going to end up being 90 minus 59, 21 degrees. Is that right? Double check myself. 180 is 90. 31, sorry. 90, yeah. So theta is going to be 61. And here I should have written the sum of the angles in a triangle. Okay, so I'm using my Euclidean geometry, some of the angles, to find angles on my Cartesian plane. All right, find the coordinates of S. Well, just now we said, well, we read that this was on the x-axis, so the value of the x value would be an x and the y value would be a 0. So there are different ways of doing this. You could just work with the collinear points. We could say Q, S, and R are collinear. So we could say the gradient of QR has to be equal to the gradient of QS. Okay, equal gradients, common point, because they're collinear. Right, so we could actually just, we could calculate the gradient of QR, but this would be quicker. We worked out in the first question that the gradient of PQ was equal to 3 over 5. So if the gradient of PQ is 3 over 5, then the gradient of QR, because they're perpendicular, must be negative 5 over 3. And if you worked it out, you'd still get negative 5 over 3 by subtracting. Okay, I'm just being lazy but clever, if that makes sense. Okay, so negative 5 over 3 is equal to the y at Q minus the y at S over the x at Q minus the x at S. Okay, now let's see. Q is 6 and 3, and S is x and 0. Okay, so negative 5 over 3 is equal to, can I just write here, PQ is perpendicular to QR. Sorry, negative 5 over 3 is equal to 3 minus 0 over 6 minus x. Okay, so negative 5 over 3 is equal to 3 over 6 minus x. All right, so now what we can do is we can either find a common denominator for both sides, or we can cross multiply. I'm just going to do it like this quickly. There's my common denominator. So this one's going to have to get multiplied by 6 minus x, and this one's going to have to get multiplied by 3. All right, so cross multiplication will give you exactly the same thing. So negative 30 plus 5x is equal to 9. Removing my brackets. So 5x is equal to 39, and x is going to be 39 over 5. And let's just check that out. That's going to be 7 and 4 over 5. I just want to check if it's a feasible answer. Well, that's a 9 at R there. So it's very possible that the x value here could be 7 and 4/5. So S is going to be 39 over 5 and 0. Okay, the other way you could have done it is to have worked in this triangle here. We just worked out that angle of this theta was 31 degrees. Okay, so what I could have done is I could have worked out the length of that side. So I could have used trig. Okay, so for this side, I want the hypotenuse. I know the adjacent. So I could have gone cos of 31 is equal to adjacent, which is square root of 34, over hypotenuse, which is what I'm looking for here. And then I could have got my hypotenuse by doing the root of 34 divided by the cos of 31. So root 34 divided by cos of 31. Just make sure that your calculator is in degrees. And that's going to give me 6,8025. Okay, and if you look, if P is the x value 1, and this is 6,80, if I round it, okay, and I add those together, 1 plus the 6,8 would give me 7,8. Therefore, x would be 1 plus 6,8, which is 7,8. So I would have got S as 7,8 and 0, and 7,8 is the same as 39 over 5. So you could also actually use trig in this triangle here if you would like to try that way as well. You're going to get the same answer. So these are both solutions to the same question. Right, is that it? Yep. Okay, so that was the exam question in 2018 in November. And what I wanted to show you was that you need to read through everything before you start. Make sure you put all your information on your diagram. And then you need to know your formulas, obviously. And also you need to think outside the box. Think of other ways of looking at things. Think about using Euclidean geometry and maybe even trig if you wanted to be able to calculate answers in this section.